Okay. So if you have any question from last lecture, you can ask.
Okay.
No question?
No.
Okay. I will send this recording to you, inshallah. But yesterday's like a lecture recording, I just mistakenly deleted it. Okay. So in now in today's lecture, we will discuss electron affinity. Okay. Electron affinity of group 16 and 17 elements. So group 16 elements are basically oxygen. These are given in this table. Oxygen, sulfur, selenium, tellurium. Okay, and you can see that the value is becoming more exothermic as we move from top to bottom in a group 16 or group 6. It is also called as group 6 of the periodic table. So minus 141, minus 200, and minus 195 and minus 190. So it is getting more exothermic. Okay, more negative. It is getting more negative, and more negative means more exothermic. So in general, you can see that in group 16, when we see the periodic trend of electron affinity becomes more exothermic or more negative as we move from top to bottom in a group of 16. Okay? And the reason is because as we move, let's say for oxygen, oxygen belongs to group period 2 of the periodic table, so it has only two shells. Okay, we have discussed in last lecture that electron affinity depends on three factors: nuclear charge, atomic size, and shielding effect, right? And
Yes.
shielding effect. So when we look at the these structures, oxygen, sulfur, and tellurium, and they draw their structure. For oxygen, oxygen has a structure, it has 2 electrons in first shell and 6 electrons in the last shell. But for sulfur, sulfur has 3 shells. Okay, it has 2 electrons in first shell, 8 electrons in second shell, and 6 electrons in the last shell. Okay, in the same way, tellurium has 4 shells. Okay, so the size of the atom is increasing or decreasing as we are moving from top to bottom. Size of the atom is
Increasing.
increasing, and we said that as the atomic size increases, it is inversely proportional to the electron affinity. So electron affinity will decrease. Okay, it decreases. So you can see from group 16 as atomic. So you will explain like that in your paper. They will ask why in group 16 the electron affinity decreases down the group. So you will explain by writing these 3 points. First of all, you will explain it by atomic size, because as we move from top to bottom in a group 16, atomic size increases, and atomic size is inversely proportional to electron affinity. So it means electron affinity will decrease. So you can see that it is going in the more negative value, and more negative means lesser value, right? Okay, Vaseem, okay.
Yeah, okay.
Yeah, okay. And then you will explain by nuclear charge. Okay, now tell me that nuclear charge is increasing or decreasing as we are moving from top to bottom in group 16. Nuclear charge will increase or decrease. Nuclear charge means nuclear attraction toward outermost shell. Hmm?
You
Okay,
repeat?
yeah. Just compare these three elements: oxygen, sulfur, and selenium. Okay, and tell me that nuclear charge, which one has the highest nuclear charge? Nu-
Has nuclear charge.
nuclear charge means nuclear attraction toward outermost shell.
Yeah, first one has the strongest, yeah.
Very good.
Towards north.
Very good. That's correct. Okay. So it means the first one, because the distance between the nucleus and outermost shell is the smallest in this one. So obviously it will have a larger nuclear charge. Then secondly, you will explain by using the term nuclear charge. Okay. Nuclear charge is basically the attraction between the nucleus and outermost shell. So just write as nuclear charge decreases as we move from top to bottom in a group. Okay. So
Yes.
nuclear charge decreases, it means nucleus has less affinity, less attraction for incoming electron. Okay, so it means it is difficult to add electron in this type of atom that is bigger. Okay, which has less nuclear charge. So you can say that that's why electron affinity decreases. Okay, so it's important to write all 3 points and explain these 3 points in writing the answer. Otherwise, you will lose marks because most of the in most of the paper this is 3 mark question. Okay, so you have to explain one by one. So each factor has 1 mark. Okay, third one is shielding effect. Okay, now compare again oxygen, sulfur, and selenium, and tell me which one has the highest shielding effect. Shielding effect is basically the okay. So do you remember what is shielding effect?
Shielding, as in which is like more, has more shielding, like more, or
Shells. Mhm.
more of these electrons.
Yeah, very good. Basically, it is the repulsor of electron because all the shells, these shells, contains electron, right? And these successive electrons in each successive shell repel each other because of their same charges. All electrons have same charges. So electrons in the successive shell in repel each other. As a result of repulsion, each shell goes very far away from each other. The shell repel each other due to the electrons, and then they are very far away from each other. Okay, so as a result, size of the atom increases because obviously, if shell move farther away from the first one, it means size of the atom is increasing, right?
Yes.
Yeah. So now tell me which one has the highest shielding effect. Means it
High
more
shielding, S, E, yeah.
SE. Very good. That's correct. Okay. Because it has more shells for shielding effect. Just remember that S for shielding and S for shell. So you have to count the shells. Which one has highest number of shells? So that one has more shielding effect. There will be more repulsion in this element. So that's why its shielding effect is higher. Okay. So as shielding effect is higher, it means the size of the atom will increase. Obviously, because molecules, these shells will be very far away from each other, it means nucleus will hold less attraction toward the outermost shell. Okay, so it is difficult to add electron in this compound because nuclear charge now is less. Okay, so shielding effect affects atomic size plus nuclear charge. So that's why if it increases atomic size and decreases nuclear charge, so obviously it will affect the electron affinity also. As if shielding effect is higher, electron affinity will be lower. Okay.
Uh,
Yeah. In most of the group of the periodic table, the shielding electron affinity decreases down the group. But fluorine in group 17, when we look at the group 17, trend is same. Okay, you can see from chlorine to bromine, trend is same. You can see it is going to the more negative value. Okay, but in this,
yes.
yeah, now you can see in chlorine and fluorine. Okay, in chlorine and fluorine, minus 32, chlorine has less, a less negative, you can say less negative than chlorine. According to the general trend, it should be like this. You can see in the group 16, in group 16, it is going to the more negative value. But in group 17, fluorine and chlorine are showing exceptional behavior. Basically, fluorine is showing exceptional behavior. Okay. Why fluorine has more electron affinity than expected? Reason in the question, they will ask you the reason why fluorine has the exceptional behavior for electron affinity because fluorine has atomic number of 9. It means it has 9 electron in its structure. So just write its structure 2 electron in first shell and 7 electron in the last shell. So it needs only one more electron. Okay. First thing is, and its size, you can see its size. It has 7 electron already in outermost shell and its size is so less. Okay. So it can easily attract, its nucleus has very strong power to attract electron in the structure. Okay. Because of its less size. So you will write answer is due to decreased size or small size of fluorine it has more nuclear charge. Nucleus can hold more electrons. Okay, so it is very easy for fluorine to attract electron from the incoming electron and add it in the structure because its size is very small. Okay, so just write this one reason and then you will get 1 mark. Okay,
Okay.
yes, so that is why fluorine shows exceptional behavior. So you can see
Could
fluorine
you
is a,
repeat that part again?
yeah, yes, definitely. Fluorine is an exception and has lower electron affinity than chlorine. Reason is because when we look at the structure of fluorine, it has only two shells, 7 electrons. It has only two shells and it needs only 1 electron to complete its outermost shell. After taking one more electron, it will become stable. Okay, so why it is it show and it has a small size. So small size means more nuclear charge, right? Its nucleus is very strong to attract incoming electron. Reason is due to small size, right?
Yeah.
Yeah, so that's why there will be and when we look at the structure of fluorine, it has high electron affinity. Okay, high electron affinity, high electron density means 7 electrons are present in the outermost shell. So let's draw 2 and 7 electron in the outermost shell. 1, 2, 3, 4. So there are a lot of electron in the outermost shell. 7, it means maximum. Maximum are 8. It has only one less. So it is electron density is higher. Okay. Electron density basically means there are more electrons present in this region. Okay. Okay.
Yeah.
So when an incoming electron is being added in the fluorine, first thing is due to its small size, nucleus holds much power to attract electron. Okay. And then when it is added, obviously, as we said, the already present electrons will repel electrons, right? It happens in all elements. The already present electrons will definitely repel the incoming electron. Okay. But if nucleus
Yeah.
has more power, so these repulsive forces are we can overcome these repulsive forces because the attraction of nucleus is much more higher than these repulsive forces. Okay,
Yes.
clear?
Okay.
So that's why we can easily this nucleus of fluorine can easily attract electron and it is added in the system and it makes this the electron affinity of fluorine less exothermic. Less exothermic means electron affinity is higher. Okay, less exothermic because basically exothermic is the term used for negative. So if it is less negative, so it means the value is getting higher, right? Let's say if you have two values minus 342 and second is minus 312. So which one is the bigger one?
Bigger in number is 312, but
312.
bigger in negative. Yes.
Yeah, so it is more exothermic. Okay, more exothermic means more negative and smaller value. Okay, more negative. And this one is higher number. So electron affinity is of fluorine is higher and less exothermic due to these all these features. First of all, atomic size, and then there are also repulsion. But these repulsive forces are, you can say, overcome by the attractive forces of nucleus and the electron. Okay, because nucleus has much more power. The main thing is nuclear attraction. If it is, it can overcome the repulsive forces. It means the nucleus can easily add electron in its structure. Okay.
Yes.
Yes. So this was all about lattice enthalpy and uh, hydration energy. No, not hydration energy. We have discussed electron affinity, right? Okay. Now we will discuss basically these presentations. Okay. Just revise it by present. Can you see the screen?
Yeah.
This PowerPoint presentation. Hmm?
Yeah. Yeah.
Okay. Okay. So first is So we will revise it by using this. Okay, give values for the standard conditions of temperature and pressure. So do you remember what were the standard conditions of temperature and pressure? Temperature,
Yeah, standard temperature was 298 K,
very good.
and standard condition was 1 atmospheric pressure.
Yeah, very good. Define the term enthalpy change. Mhm.
Enthalpy change is when 1 mole of an atom is converted to a gaseous form
Yeah, very
using
good.
standard.
Or you can just write energy change because they said energy enthalpy change, not enthalpy of atomization. So you can just write energy change, total heat energy change, or just energy change during a reaction. Okay.
Yeah, okay.
So it is represented as del H is represented as del H of product minus del H of reactants. So that's how you will explain this question. Okay, because they didn't say enthalpy of atomization. So it is not necessary to write gaseous and all these things. Just write enthalpy. They just said enthalpy change. So basically enthalpy change is a heat energy change during a reaction. Okay.
Yeah, okay.
Then what do you mean by ionization energy? As the name indicates, ionize. An atom gets ionized when it loses or gain electron. Okay. So ionization means when 1 mole of atom, okay, no, energy, ionization energy is energy required. So all these definitions are very important. Energy required to remove electron from isolated gaseous atom. Okay. So it means first of all we will convert it into isolated gaseous. Isolated means single gaseous atom. Let's say if we have chlorine, okay, chlorine gas, first of all we will convert it into isolated atom like 2Cl atoms in gaseous form, and then we will remove 1 electron from chlorine atom. Each chlorine atom will donate 1 electron. Okay, 2 electrons are removed from chlorine, right? And now the energy required for this reaction to remove electron from this atom is called ionization energy. Okay.
Yeah, okay.
Yeah, energy. So basically, ionization energy is totally opposite to electron affinity, because electron affinity was energy required to add electron in the outermost shell of an atom, and ionization energy is to remove electron from outermost shell. So these are opposite to each other. Okay.
Yes.
Next is standard. Okay, answers are given. Del H, you can see in and the first ionization energy of element is the energy needed to remove electron from each atom in 1 mole of atom. So this all these definitions are very important. Okay, and you have to write as it is. You cannot write definitions in your own words. My suggestion is write as it is. Okay. Then lattice enthalpy. Define and use the term lattice enthalpy. Okay, can you explain what is lattice energy in your own words?
Um,
Mhm.
um, lattice energy.
Mhm.
Lattice energy is the energy when 1 mole. Is it that the same meaning when the 1 mole of
Mhm.
uh, uh, gaseous ion is formed
Yeah.
under standard condition?
Uh, okay. We have studied that lattice. Okay. So, what was lattice? We have studied what is lattice. A special class of compound make lattice structure. So you have to add the name of this compound also. Ionic compounds. Okay. In the definition, you should write that one energy released when 1 mole of ionic compound is formed from its gaseous elements. Let's say we talk about sodium chloride. So when 1 mole of sodium chloride is formed from its element, sodium and chloride, and then we say gaseous atom. So gaseous atom.
Basically, whenever they say about lattice word, we add the ionic compound.
Yeah. For
Okay.
now, you should remember that lattice is used for ionic compound in physical chemistry. Obviously, there are some compounds of covalent compounds also that can make lattice structure, but these are different. For physical chemistry and for this type of question in enthalpy change of atomization, just remember we are talking about ionic compounds. Okay.
Okay.
Yeah. And so energy released when NaCl or any compound is formed from its ionic gaseous atoms. Okay. Then okay, the most favorite one, enthalpy change of atomization as the name
I think
indicates. Mhm.
when 1 mole of the atomization is
Mhm.
1 mole of gaseous atom is formed.
Very good. That's correct. Mhm. Basically, when an atom is converted into its gaseous form, atomic gaseous form. Okay. This one was solid. From solid to
Yeah.
gas or from liquid to gas, when it is converted into gaseous form, it means it is into
Basically, anything
atomic. Sorry.
turning to gas form.
Anything turning to gas form and it in atomic state. Let's say if we convert Cl2, now it was a molecule. Cl2 is a molecule, okay, and it is in gaseous state already. So if it converts to atom form, like if we write 2Cl, it means now we have 2Cl separately, okay. But in this Cl, these Cl were bounded together, okay. So now if we convert molecule into gaseous form of atomic gaseous form, it is also atomization. Okay, so I'm telling it over here because there will be some reaction in which we have already chlorine in gaseous form, and then we will convert it into atomic form, and then the state is gaseous again. Okay, that's why you should remember there is another possibility also. If you convert it in atomic form, this is also atomization. Okay,
Okay.
yeah, but for obviously for solid to gas or liquid to gas, the enthalpy of reaction would be enthalpy of atomization. Okay, now can you explain electron affinity?
This one I'm not sure about it.
It's okay. Just try. It is
Electron affinity is, yes, I say or no.
basically electron affinity. Affinity means attraction, right?
Yeah,
When
so it's like
yeah,
one mole of electrons. Yeah, it's about the
mhm.
electrons. 1 mole of electron is formed from 1 mole of gaseous atom. Yeah,
Electron.
understand.
When 1 mole of electron is how much energy is energy released when 1 mole of electron is added in a gaseous atom. Okay.
Yeah, okay.
Yes, when it is added, because obviously electron, we cannot form electron, so we cannot write when 1 mole of electron is formed. No, when 1 mole of electron is added in 1 mole of an atom, is called electron affinity. Okay. So these are lattice energy, the value of, okay. The most important thing in gaseous ion, it is lattice energy is always exothermic for ionic compounds. Okay, it is always exothermic. Okay,
Yeah,
then and due to the presence of sodium chloride, because when two ions react with each other, there is a attraction. This type of attraction is called strong electrostatic attraction. We have learned in last lecture what is electrostatic attraction. Whenever positive and negative charges attract each other in a compound, the resulting bond is called electrostatic attraction or ionic bond. Okay.
yeah, okay.
Yeah. Then okay, right equation describe the lattice energy of magnesium oxide, potassium bromide. So these are the equation. For equation, you have to write all the bonds. Which basically the charges. Okay, Mg plus 2 as you have written in the last lecture, O minus 2, but state symbols are also important. Okay, Mg plus 2 and gaseous oxygen is added and then sulfur. Okay.
Yes.
Yes, and when we are saying lattice energy, it means elements must be in gaseous state. In normal state, we know that magnesium is in solid state. So, but in this question, you will not write solid because we are saying the lattice equation. So, lattice energy equation would mean gases. All the atoms would be in gaseous state. Okay, because according to definition, when 1 mole of a compound is formed from its gaseous ions. So these ions should be in gaseous state. Okay, clear? Any question?
No, I understood.
Okay. Then next one. Enthalpy change of atomization is always endothermic, and we have discussed why it is endothermic, because it involves breaking of bonds. Okay, as you said, enthalpy change of atomization is conversion of, let's say, solid into liquid, solid into gas. In solids, molecules are close to each other, and when we are converting a solid into gas, it means molecules are now very far away from each other. Okay, so in enthalpy of atomization, actually we have broken the bonds between each particle, okay, each molecule. So that's why breaking bond is always endothermic. It needs energy, we have to supply energy, so that's why it is always endothermic. Okay, so just remember that enthalpy of atomization would be positive, and all other enthalpies like lattice energy, lattice enthalpy, electron affinity, all others are positive negative in nature, but enthalpy of atomization would be endothermic, positive. Okay,
Yeah,
because we said bond breaking. So any process that involves bond breaking is endothermic, and any process that involves bond formation, as we said, lattice energy, lattice enthalpy, it is exothermic. Okay.
yes.
Okay. The bond energy of the chlorine molecule is plus 244 kilojoule per mole. Why is the standard enthalpy change of atomization half this value? Okay, right. Okay, first of all, this said that the bond energy of chlorine molecule means Cl2. Okay, its bond energy is plus 244 kilojoule. Why is the standard enthalpy change of atomization is half of this value? Okay, bond energy means energy required to break this bond, chlorine fluoride bond. Okay, the term bond energy means energy required to break this bond. Okay, so whenever we break this bond, plus two, it absorbs plus 244 amount of energy. There, and in the question they said why standard enthalpy change of atomization is half of this value. Can you answer? Any idea? Just make a guess.
Of
This first one, first question.
basically those that table that had all the numbers using that, yeah.
Mhm. So how this is related to atomization energy? Okay, so first of all, explain atomization energy. Okay, so you will say that bond energy is 244, and atomization energy means like we are breaking the bond already. Atomization also means that we are converting it into two chlorine molecules, atoms. Okay, so we are breaking a bond. Okay, so
Yes.
that it is half of this value, because we use atomization. We are just breaking a bond. Each chlorine will have different enthalpy of atomization. It is converted into gaseous state. It is also converted into gaseous state. So that's why its
Is it like
enthalpy.
you have to make an equation?
Sorry,
Like the equation you have to make?
if you write equation, then it would be clear for you.
You could also do like 1 by 2 Cl,
Yes,
Cl.
definitely. Yes, you can do it like this, one over half. Yeah. Okay. So it's up to you. Okay. Let's say, okay, when one, because, yeah, you can answer like it like this, half Cl2, because atomization means when 1 mole of a substance is converted into gaseous state. Okay. So there is only 1 mole. So you can divide it by two. Yes, definitely you can do it like this. Okay.
Yeah.
Yeah. Both methods are correct. Next is write equations
Okay,
including,
for these also it's the same, yeah. The for this oxygen and barium 1 by 2 O gives
definitely.
just, yeah, okay.
Yes. Definitely. Okay. So you can see enthalpy of atom. As you said, you can write both equations. Cl2 is converting into 2Cl, and then half Cl2 is converting into chlorine. So this is enthalpy of one. So when we use half chlorine, so obviously enthalpy of bond energy would be half. So divided by 2, you will get plus 1 by 2, 122. Okay.
Yes.
Yeah. Then for oxygen, yeah, you will do like this, as you said. But for barium, barium is solid. It is a metal. Okay, you will write half only for diatomic molecules like chlorine, Cl2, oxygen, O2. If written N2, then you will write half. If a compound has O2, N2, H2, like this structure. Okay.
Yes.
Yeah, but for this type, the barium is a metal. It exists as a solid state, so you can easily convert it into gases. So for barium, it would be like this. Okay, next, electron affinity. We have discussed electron affinity. Okay. In last lecture, we have discussed enthalpy of electron enthalpy change when an electron is added in a system. And we said first electron affinity is always exothermic, and second and third electron affinity is always endothermic. Can you explain why?
Why it's the
Mhm.
Cl is exo, yeah?
Yeah, no. Why first ion? Okay, I think this is in next slide. This one. Yeah. First electron affinity of any compound is negative, more exothermic. You can see.
Oh, it's in exothermic, of course, because it's like the more energy is released, like see it's
Yeah,
negative 141, and the
definitely
other one is endo. It's in positive, more energy is not that energy is not released. That means
absorbed. Okay, so
absorbed, yeah, more energy
yeah,
absorbed.
very good. But why atoms is same? First is also oxygen, second is also oxygen. So why first ionization energy is exo and the second is endo? Any reason? Because these are same atoms. So how in first electron affinity is exothermic, but second is endothermic? Because when we add first electron in it, let's see the same structure. Okay, when we add one electron in any structure, it becomes negatively charged, right? It means now it gains electrons and now it becomes negative charge, right?
Yeah,
Second electron affinity means that we are adding one more electron. Okay, so when we add one more electron in the structure, this now incoming electron is repelled by this and the already present electrons. Okay, so for adding second electron, we need to provide energy. Okay, so when we are providing energy, so that's why it takes energy, it is endothermic. Okay, for first
yes,
electron in affinity, we don't need to provide energy because it is very easy for an atom to attract electron. But for second electron affinity, we have to provide energy to the system. So when we are providing energy, so that's why it becomes endothermic. Okay,
yeah,
yeah, this is very important question. And then total electron affinity would be electron affinity 1, and then add both of these, and then you will get electron affinity of oxygen atom as a whole. Okay,
yeah,
then they are also saying suggest why second and third electron affinities are always endothermic. So I have explained already that because say for second electron to be added in the system, it is repelled by incoming electron. So answer is there must be an input of energy to overcome the repulsive forces between the negative electrons and the negative ions. Is that clear?
oh, yeah,
Yeah. Then trends in electron affinity. When we talk about the metal, okay, we have discussed it in this lecture. Oxygen, so it is in group 16. It is going to more negative value. It is electron affinity decreases down the group. Okay, for oxygen it is minus 141. For delirium it is minus 190. Okay, so it means it is decreasing down the group. Okay, but for
yes,
halogen group 17, the trend is same, but now you can see for fluorine it is fluorine shows exceptional behavior, right? And we have discussed why fluorine shows exceptional behavior. Its electron affinity is higher than chlorine. So can you explain why fluorine has exceptional behavior? We have discussed in detail.
The electron affinities.
Mhm. For fluorine is higher than that of chlorine. Okay.
Yes, because uh, fluorine has only two shells, whereas
Very
chlorine
good.
has one.
Yeah. So for two shells affect nuclear charge.
Charge is less. Yeah.
Yes. So you have to write all the things. First of all, shells. Okay. Then you'll write it affects the atomic size also. It means fluorine has smaller size. Smaller size affects nuclear charge. So there will be more nuclear attraction toward the outermost shell. Okay. So you have to explain all these three things. Then you will get full marks. Okay.
Okay.
Yes. Okay. Next is, okay. So answer is given. It's better to just memorize the answer. Okay. Because in your mark scheme is very specific. Okay. They expect to write some special type of, you can say, uh, the terms like greater repulsion, more attractive forces. Okay. Like this. We have to explain. Just keep in mind that you have to explain atomic size, then repulsion. Okay. These two, and then nuclear charge. So when you explain these three things, then you will get full marks. Okay, keep in mind these three things and then explain, and then you will get full marks. So you can see the answer.
Yes. Okay.
Fluorine doesn't fit the trend. The electron affinity of a fluorine atom is lower than that of a chlorine because atomic radius, first of all, note it down, atomic radius of fluorine is small. Then they said the high electron density causes greater repulsion, second point, and between the electron, and this greatly reduces the attractive effect between the incoming electron and the nucleus. So basically they are talking about nuclear charge. Okay, so you can see in the paragraph they said all three factors. Okay, so in this way you will explain. If you lose or if you just miss one of the factor, then you will lose marks. Okay, because examiner will just see the term atomic radius is written, yes, written. Okay, then 1 mark for greater repulsion, 1 mark for nuclear charge, 1 mark. Okay, so you have to explain all 3 points, then you will get full marks. Okay.
Yes. Okay.
Yes. Now applying enthalpy change of calculations. In this one, there is just a real life application for lattice energy. It is used to evaluate the electron relationships and fluoride relationship. Um, we can find out the enthalpy. Okay, we will discuss Born-Haber cycle today. Born-Haber cycle. Then you will know that why we are calculating these energies, electron affinity, ionization energy, and this uh, ionization energy as well. Okay, lattice energy. So these are important to find out enthalpies, different type of enthalpies. Okay, and then it will let you know that whether a substance is able to dissolve in water or not. Okay, because obviously this lattice energy means it contains ionic compound, so it means that it is soluble in water. Okay, so for this purpose, for in order to find out the solubility of a compound and other physical properties also, some hardness and volatility, we use lattice energy. Okay.
Yes. Okay.
Yeah, so if it is lattice energy is more exothermic, it means a lot of energy is released in making of that ionic compound. So if a lot of energy is released, let's say plus sodium and chloride, for the formation of sodium chloride, it is minus 787 kilojoules. So it is more negative. It is very exothermic. It means a lot of energy is released. Okay, it means a very strong type of bond is present between sodium and chlorine. So sodium and the property of sodium chloride is it is hard. Okay, so by looking at just chemical this lattice energy, we can find out whether a compound is hard or soft. If it has more exothermic latent enthalpy, it means it has very strong bonds. Strong bonds means it is hard in physical, you can say, appearance. If it has less exothermic lattice energy, it means it is soft. So that's why we are calculating all these energies in order to find out the you can say physical and chemical properties of a compound. Okay.
Yeah, okay.
Yes. So this is end of this chapter. Okay. So you should be able to write all type of electron affinities in the equation form and in the all. So best thing is, first of all, know that you have to write gaseous form while writing electron affinity, while writing lattice energy, okay, and while writing atomization energy. State symbols are important. Okay.
Yes, okay.
Any question?
No.
No question. Okay. Okay. Next topic is Born-Haber cycle. Okay. In this lecture, we will just discuss the, you can say, introduction of Born-Haber cycle. Okay. It
Can you go
is
back to the once again?
Born-Haber, sorry, what?
Can you go back to the PPT?
Yes, definitely. Yeah. Mhm.
Go to the previous PPT.
This one?
Not this. That one, the 20. No, no. One more up. Here, the lattice energy, why does it have two? It's just
Sorry.
saying about two type of properties.
Sorry. Practical properties.
And the other one,
Sorry, Vasi, I can't hear you properly. Can you speak a little more clear?
you go to the 24th slide.
24th slide. Okay. This one. Okay.
Here's this third one.
Third one. What is the numerical value of the enthalpy change of atomization of helium? Okay. Okay. In the question, this. Okay. Helium is already a gas, right? So enthalpy change of auto, and it also already exists in atomic form. So all the noble gases are all those elements that are present in group 8 of the periodic table or group 18 of the periodic table. These are helium, neon, krypton, and so helium is one of them. It All these gases exist in atomic form, means in the single form, and they are gases obviously. So they said, what is the numerical value of enthalpy change of atomization of helium? And enthalpy change of atomization means we are converting it into gaseous form, okay, and atomic form. So when it is already in atomic form and gaseous form, so we cannot convert it into. So why would we convert it? So its enthalpy change of atomization is 0. Okay.
Yes.
So because it is already a gas, already in atomic form, so obviously we cannot convert it. So that's why we will write 0. For all noble gases, it would be 0. Okay.
Yeah.
Yes. Okay. Any other question?
No.
Okay. Then next is Born-Haber cycle. Okay. Born-Haber cycle is shown to show the lattice enthalpy, to find out the lattice enthalpy of ionic compound. Basic purpose is to find out the lattice enthalpy of compound, because in some questions we cannot find it directly. Na positive, let's say, for sodium chloride, we cannot find it directly. So for this one, we use alternative method, alternative route to find out lattice enthalpy of this reaction. Okay, because it involves a number of steps. First of all, we will atomize this sodium and atomize this chlorine. Then there will be electron ionization energy, then electron affinity. Okay, first of all, you need to know that there is one more enthalpy of formation, that is called enthalpy of formation, del HF. It is represented by del HF. So formation is that when one mole of a substance is formed from its elements, okay? Let's say if it is, and all the elements are in their standard state, okay?
Yeah, okay.
Yeah, so this is enthalpy of formation. Let's say when we write for sodium chloride, sodium is in solid state, chlorine is in gaseous state, half chlorine, and it is converting into NaCl. So this is enthalpy of formation. Okay, so what type of you can say the term you will use depends on the type of reaction. Okay, so we have one more type that in which sodium is present in gaseous state, chlorine is present in gaseous state, and it is converting into NaCl. Okay, but now in this reaction, the energy release would be called as del H lattice, not formation, because these two are different. For formation, note that all the elements are present in their standard state. Sodium is present in solid, chlorine is present in gases. So that's why now the energy released would be called as enthalpy change of formation. Okay. But for lattice energy, it is important that all the elements or ionic in lattice energy definition is when one mole of a compound is formed from its gaseous ions. Okay.
Yes.
Yes, so definitely both of these are different. So in this type of reaction, in the Born-Haber cycle, we want to find out sometime enthalpy of formation and then sometimes enthalpy of lattice. Okay.
Yeah.
Yes. Okay. So in Born-Haber cycle, there are a number of steps. Now you will learn how many steps are involved. These are the steps, and the sequence of steps are also important. Basically, enthalpy, first of all, enthalpy change of atomization of each element, then first ionization energy, then successive ionization energy if a metal is applicable. Let's say if we want to find out for sodium chloride, okay, we want to calculate enthalpy of sodium chloride, enthalpy of formation or enthalpy of lattice. Okay, so Born-Haber cycle starts from enthalpy of atomization. Okay, it means,
Yes.
first of all, you will take sodium and chlorine in their standard state, gas, okay, and then you want to convert it into gaseous state. So the for sodium, first of all, you will solve one by one. Okay, first of all, for one item for sodium, now the sodium is converting into gaseous sign. Okay, and write chlorine as it is. Okay, so
Yes. Okay.
now this is enthalpy of atomization of sodium, only sodium, because obviously we are not changing chlorine, so obviously it is just for sodium. Okay, then
Yeah.
in the next step, now you will write sodium as it is. Sodium is in gaseous form, and now write chlorine in gaseous form, atomic form, and then gases. Now this is the energy release would be called as enthalpy of atomization of chlorine only. Okay, because in this reaction, only chlorine is being atomized, right?
Yes.
Okay, so next is now because we have both gaseous ions, now the next point would be ionization energy. So sequence is important. First of all, atomization energy of each element, then ionization energy. Now, first of all, again one by one. First of all, for sodium, because there is only one atom that can lose electron. Ionization energy is basically that energy that is required to remove electron from isolated gaseous sector. Okay, so sodium can lose electron. Sodium is a metal, always metal lose electron. Chlorine will not lose electron. That is not non-metal. Okay,
Yes.
so sodium will lose electron to form positive charge. Obviously, we know that when an atom loses one electron, it forms positive charge, right? And the resulting energy enthalpy is called enthalpy ionization energy of sodium. Okay, again, sodium is in gaseous state, but now in positive state. You will write chlorine as it is. Okay,
Yes.
okay. Now chlorine, because it is non-metal, so just remember that the non-metal part will always accept electron. Okay, so you can write it like this. Just say, write, hmm, okay. So because we have to draw a cycle, so you can write it like this. Okay. Now sodium is already in positive state, so just write sodium as it is. Okay, but you have to make chlorine negative because we know that in lattice energy, in ionic compound, one compound is positive, other element is negative. Okay, so we have positive charge, so chlorine will accept electron. Okay, right?
Yes.
Chlorine will accept electron. Okay, so this energy would be called as when chlorine will accept electron, so enthalpy will be called as, it is, we have discussed the whole lecture. When an electron is added in a atom, it is called.
Um,
Mhm.
when an atom is
When an electron is added in a system, in an atom, the energy release is called.
atomization.
No, this is conversion of solid to gas or something. Let's say if we want to add electron in an atom, so energy release is called. Mhm. We have studied a whole lecture.
Oh, the von Haber cycle.
No, no, it is electron affinity. I see.
Yeah, but affinity was acha. Oh, yes, yes, yes.
Yes, it is attraction. Okay, so it is
Yeah.
called electron affinity. So after taking one electron, chlorine will form negative charge, Cl negative. Okay, and again it is in
Yeah.
gaseous state. Now both of these atoms will react with each other, sodium positive, and they will form
And
NaCl.
so,
Yeah, will,
when it moves from
sorry.
solid to when it moves from a gas to a solid, it's affinity.
No, when it moves from neutral to negative charge, it means it has added one electron. So after addition of one electron, this is electron affinity. Electron affinity is not related to gaseous or solid. When any atom gains one electron, the energy release is called electron affinity.
After a neutral to a negative.
Yeah.
Okay.
Okay. So this is electron affinity. Then after, now we have positive charge and negative charge. So both of these will react together to form NaCl, that is solid, and this enthalpy would be called as, just make a guess. Na and Cl, two ions are reacting together in their gaseous state to form a solid structure, that is ionic compound. Enthalpy would
Not
be,
sure. Reverse of affinity or either atomization.
no, atomization is just conversion of solid to gas. Okay, in this two,
Here is gas to solid.
yeah, and two ions. You can see not just the state symbol. Look at the ions also. Okay, positive and negative ions are reacting together to form ionic compound. So do you remember any definition which involves ionic compound?
Lattice energy.
Lattice energy. Very good. Okay, so you write now this is the lattice energy. Okay, keep in mind the definition and the process. Okay, so atomization energy is all the first step in which we are converting sodium to gas and then in the second chlorine into gas. This is atomization. After it, then there is ionization energy in which sodium releases one electron to form positive charge, then electron affinity, and then lattice energy. So this is the sequence that you have to remember. First, atomization of each element, then ionization energy, then electron affinity, and then lattice energy. Okay?
Yeah, okay.
The order is important. So I'm stopping here and then we will learn Hess's law tomorrow, same timings. Okay? This
Yeah,
is
okay.
very interesting. Inshallah, we
Yeah,
will do.
can you send the recording?
Yeah, definitely.
It's okay.
So on WhatsApp?
Yeah,
Okay. Okay.
yeah,
Sure.
okay.
Okay. Allah Hafiz Wasi. See you.
Allah.